Good day, everyone. Speaking is Jeremy of the Cebu Technological University, Bareilles campus. Through the Project SARAI Phase 2 under Project 2.1, present this study entitled Special Variation of Soil Properties in Bareilles, Cebu, Philippines using Ordinary and Simple Kriging. Dealing with the smarter approaches to reinvigorate agriculture as an industry, accurate and updated geospatial soil information is imperatively needed. The Philippine agriculture is still using over 40 years old soil information in its various programs like climate change mitigation, land use plan, and food security. Likewise, the Bureau of Soil and Water Management is still in traditional soil survey method and is yet to implement digital soil mapping. There are inefficiencies in manual or traditional soil map production. First, it is incapable to update soil surveys rapidly and accurately. Second, it cannot detect or observe easily important changes in environmental conditions. Third, the entire process must be repeated for each future soil survey update. Thus, this manual method is costly and time-consuming. And what is worse, that the maps being produced are not intelligent. Hence, in this study, we adopted digital soil mapping. It is a geospatial interpolation of soil properties since we are analyzing here soil properties. This is done by establishing spatial correlation or dependence that the degree of influence of observed point to unobserved point is inversely related to distance. This is what we call kriging. The first essential step in kriging is the calculation of empirical variogram before any geostatistical interpolation. In this study, isotropic semi-variogram is determined considering only on the effect of distance. Digital soil mapping is efficiently doable applying Geographic Information System or GIS, as GIS can incorporate spatial and geostatistical analysis. GIS is efficient in management and storage of geographic data. The objectives of this study is first to use free and open source software of R, Saga GIS, and QGIS. Second, to determine spatial correlation of soil properties, and the soil properties we have examined are the pH, organic matter, phosphorus, and potassium, applying kriging. Third is to compare the result of ordinary and simple kriging. The methodology consists of soil sampling. Then, the soils were analyzed. Results of the analysis were further analyzed adapting variography. This is to come up with a variogram models which were done using spatial and geostatistics kriging module for grade interpolation from irregular sample points of Saga GIS. After having the variogram models, geostatistical interpolations were done employing ordinary and simple kriging. Eventually, the geostatistically interpolated models were then examined and cross-validated in selecting more or less the final or best model. The study area. The study area is in Bareilles, Cebu. Bareilles is a second-class municipality in the southern part of Cebu province. It is located southwest of Cebu City. The size of the study area is around 124 square kilometers with an elevation from sea level on the western part to 540 meters above sea level toward the eastern part. The study area is mostly an agricultural land. In this site are the location of the soil samples, and they are distributed throughout the study area randomly. They are randomly sampled. As shown in this table are the results using ordinary kriging. The variograms of soil properties were fitted with linear, power, square root, exponential, stable, Gaussian, cubic, and spherical variogram models using the Saga GIS variogram module. In this study, it was observed that only pH and organic matter have spatial dependency, while the phosphorus and potassium revealed no spatial dependency. Cubic variogram exhibited the highest R-squared for both for pH and for organic matter. For pH, it has an R-squared of 39.2%, while for organic matter, it has 19.14%. The differences in errors in terms of mean square error and normalized root mean square error among variogram models are very small. Likewise, in this table are the results of variogram models using simple kriging. Similarly, cubic variogram models exhibited the highest R squared, again both for pH and organic matter. For pH, using simple kriging, it has an R squared of 41.76% and OM has, or organic matter has 19.4%. These images present the spatial distribution of pH on the study area using ordinary kriging on the left and special kriging on the right. Also shown in the images are the boundaries of three watersheds and the streamlines in black color. The results of the two kriging methods are almost without difference, or shall we say they are very similar. Out of the 177 samples, only 2 samples have pH values less than 7 and majority have pH values between 7.5 to 8.2. Hence, the geostatistically interpolated model revealed that soils in the study area are mostly alkaline. pH values are higher toward the seaside or at the southwestern part of the study area, while they are lower towards the northeastern part. Areas with pH values or with high pH values are with good drainage system, as high pH values are observed as their distance from the major streamline is nearby or closer. These images present the spatial distribution of organic matter in the study area. Majority of the organic matter values of the samples ranges from 1.5% to 4%. As depicted in the images, higher values of pH in this big watershed, this part here are the higher values, which are located at the downstream of the watershed, could be attributed by sediment deposits. So in this area, most of the rice fields are located. Thus, somehow the presence of high organic matter are attributed from the decomposed parts of rice plants. Likewise, where presence of high organic matter are attributed to presence of dense vegetation. For the conclusions, first, the study presents a successful approach in DSM with the use of Saga GIS and QGIS that are of best cost advantage to be adopted by any GIS users from developing countries like the Philippines. Second, the performance of ordinary kriging and simple kriging were very similar. Third, understanding the spatial variation of soil properties and their relation with the environment is a key to appropriate land management, particularly for crop suitability modeling, and also can be adapted very well in coming up for the comprehensive land use plan. Fourth, the results of spatial variability of soil properties in the study area indicated that the soil ecosystem is influenced by environmental covariates and agricultural practices that are needed to be investigated in depth. Thus, we have these recommendations. First, recommendation is to increase the size of soil sampling and testing. Second is to transform the data to meet the normality assumption prior to modeling. And third is to employ multivariate regression modeling to investigate in depth the influence of environmental covariates. And further investigation should be conducted on the other side of the mountain range to understand better the spatial variability of soil properties. Allow us to end this presentation borrowing the words of William Darr. This is the enormity of the challenge we are confronted with in the future, and it all starts from the basics, which is soil. Thank you, and again, good day.